Hello, today we're going to be making a 2D game in the terminal using Go. As a programmer and someone that loves a keyboard-centric workflow, I basically live in the terminal. So I thought today I would be pushing the limits of that and make a game without even opening a window in plain text and ASCII in the terminal like this. I thought I'd bring you all along for the journey and hopefully we can make something pretty cool. So with that being said, let's go ahead and get into it. So the first thing that we need to do is make a new folder for the project, and I'm going to call mine terminal game, and then I'm going to cd into that directory here, and let's actually turn it into a Go project. So the way we do that is we do go mod init, and I'm going to call mine terminal game like this. And then what we need to do is add the library that we are going to be using for drawing graphics in the terminal. That library is called Tcell, linked in the description, and the way we can add it is with go git. So we have go git, and then we have the URL of the GitHub repository. And so now we can press enter, and as you can see, Go has added the dependencies to our project. Next thing we can do is actually create our entry point here. So I'm going to open up a main.go file. The first thing we have to do is specify that we are in the main package. So we do package main there, and then do this function main like this. The first thing I'm going to do is make sure that my environment's set up correctly. So I'm going to add a little print statement here with a hello world like so. So then I'm going to do a go run dot to make sure that everything's working, and it is. So that's great. Now let's go ahead and actually start working with this library. So the first thing we need to do is initialize this object called the Tcell screen. And so the way we do that is with the tcell.newScreen function here. Now, if you look at the signature of this function, it returns the screen and an error. And so what we need to do on the left side of this is unpack it into two values, so the screen and the error. The screen is going to be what we actually use for interfacing with all of the different things we need to draw graphics onto the terminal. And then the error is any possible error that happens whenever we are creating this new screen object. So what we need to do now is we need to actually handle this error. So we'll say if error does not equal nil. And now if we're unable to create a new screen object, we actually can't do anything with our game. So what I'm going to do is I'm going to do log.fatal, which will basically just exit the application with an error here. So now that the screen has been created, we need to initialize it. So we can do a screen.init here, which will initialize our display. And if we look at the function signature, it also returns an error because there is a possibility for the screen to not be initialized properly. So now what we can do is put error equals on the left side here, and again handle the error. So if error does not equal nil, then again, if we don't initialize the screen, that's pretty bad. So we want to log the error fatally like this. Now the screen also needs to be cleaned up. So right after I create the new screen, I'm also going to defer a screen.fini call, which is the function for cleaning up the screen. Because this is interfacing with terminal stuff, which does not always have memory managed systems like Go does. So we need to explicitly call the fini for cleaning up some resources that we're going to be using. I'm using the defer keyword here so that I can put the call right after I initialize the screen. This is just so I don't forget to stick it at the bottom far away from wherever I'm actually creating it. So now that we have the screen initialized, we need to actually enter the game loop. And if you're not familiar with game development and what a game loop is, basically a game loop loops while the game is running and updates the state of the game and draws the game to the display target, in our case, the terminal. And so what I'm going to do is I'm going to create a new section here called the game loop, and then we will basically just do this pseudocode. So we'll say like while running, update state, draw screen, else we want to close. So we need to sort of represent this in code. And the way we can do that is we can first have a flag for the running state. So we'll say running is true, and then we'll create a while loop, but there is no while loop in Go. So it's going to be a for loop for running like this. And then while we're running, we need to do the update logic, and we need to do the draw logic. So for the update logic, since we have an infinite loop, we need a base case to be able to break out of it so we're not just stuck in this infinite loop. And for that, we're going to be polling for events. So I'm going to do an event : equals, and then the screen has a function for this. So it's going to be screen.poll event like this. Now what we can do is we can look at the type of event, which is a tcell.event. If we go to the definition of what an event is just an interface that provides us with one function for when the event happened, and that's not enough information for us because for me, I want to close the application whenever the Q key is pressed. Luckily, there is a way to get around this, and we can actually do that by checking explicitly what the type of this event is. And so for that, we can make a switch statement, and we can say event : equals the event, and then in parentheses, parentheses, the type. What this will do is it'll basically switch over the different types that the event can be. So what we want to do is add a case statement for the event type that we're looking for, which in our case is the event key. And then what we can do is we can say if it's an event key and we type in event, if we look at the type here, now the event has changed to the type of a pointer to an event key struct. So up here, it's just in event interface, but because now we have more information about it, we can then assert that it is an event key struct. So what does that mean? That means that we can have an inner switch statement in here. We can say switch the event.rune, which basically is the character corresponding to whatever key we press. And then we want to add a case statement for quitting. So we'll say case. And for me, I want Q because it makes sense, Q for quit. If we do press the Q key, we want to set running equal to false. And then that should be the entire thing. So what are we doing here? We are getting the event. Then we are checking the event type. And then we are checking the event key like this. So let's test this out. Let's do go run dot and test the game. And as you can see, we now have a blank window. Our prompt is gone and everything. But if we press Q, we go back to how we were before, which basically what that was we were entering our for loop and then we broke out as soon as we pressed the Q key. But having just a blank window like that is very boring. I wouldn't really call it a game. So let's go ahead and actually add some stuff to our draw logic here. So inside of our draw area, I'm going to add two things. I'm going to add a screen.clear and I'm going to add a screen.show in that order. So we're going to first clear the screen and then we're going to show the screen. Clearing the screen basically just wipes all the stuff that we previously drew on the screen, and show basically presents all the stuff that we built up in our display buffer using the set content. So in between here is where we want to draw all of our stuff. To actually draw something on the screen, what we can do is we can use screen.setContent, and here it takes in a few values. We have the X, the Y, the rune or the character, the combining, which is a list of runes, and we're just going to leave that nil for now. And then the style is going to be the style, like the highlighting, the colors, all that sort of stuff. And so what I'm going to do is I'm going to add in, let's say 10, 10. And for the character, I'm going to put the @ sign. And then for the combining, I'm going to put nil because we don't need anything. And then for the style, I'm going to put style default like this. Now it's important to note that the coordinate system of the terminal starts at the top left. So where my cursor is, this is going to be 0, 0, and this is going to be your number of rows and number of columns at the bottom right here. So when I put it at 10, 10, it should be somewhere around this area right here. So let's go ahead and test this out with go run dot. And as you can see, we have a character on the screen. Very cool stuff. But it's not really very interesting because we can't move our player around at all. It's just kind of stuck at 10, 10. So what I'm going to do is I'm going to create a new file and I'm going to call it sprite.go. And in here, I'm going to make sure that we specify that we're still in the main package, and I'm going to create a new struct and call it sprite. So new type sprite struct here, and then inside of here, we need three things. First, the character representing the sprite, so char rune, and then the X and the Y position of the sprite. I'm going to create two functions here. The first function is going to be a helper function for creating a sprite, so func new sprite here, and this returns a pointer to a sprite object. And I'll just say like you need the rune and you need the X and the Y of the sprite. Then we will return a new sprite object like this, and then just map them to the values in sprite, so X, X, Y, Y. The second function that I'm going to make is actually going to be a method attached to the sprite object. So I'm going to do func in parentheses S, and then we're going to capture a pointer to sprite. And then I'm going to say draw. This is going to take in the screen object, which is just a Tcell .screen interface. And that's all we need for that. So then what we can do is we can just say like screen.setContent. And for the X and the Y, I'm going to do s.x and then s.y and then s.char. And then for the combining, it's going to be nil. And then for the style, it's going to be tcell.style default like that. Back to the main.go file, we can get rid of this set content here and we can create a new section. I'm just going to comment it off here and say this is our game init section. So this section is basically for initializing our objects. And then I'll create a new variable called player and I'll assign it to a new sprite like this. For the character, I'm going to put the @ again. And then for the position, I'm going to put 10 and 10 again like this. And then inside of the draw logic, I will replace that set content with player.draw and pass in the screen like this. But we haven't actually gained anything from using this new sprite object, and that's because we aren't actually doing anything with it. But now that we're keeping track of the X and the Y position of the player in variables rather than just hard-coded 10 and 10, we can now respond to keyboard input like this. So let's go to wherever we are detecting for different keys, and let's add a couple more case statements. I'm gonna do W, A, S, and D. So I'm gonna do W here. Whenever we press the W key, we want the player to move up. So we will do player.y, and then we will do minus equals 1. Remember, it's minus because the coordinate system is from the top left down instead of from the bottom left up. Then let's just copy that statement and paste it a few times. So then we'll do A, S, and D. And then for A, we want to move the player to the on the x-axis by 1. For S, we want to increment the y, and then for D, we want to increment the x by 1. So like that. Now what we can do is we can do go run dot, and if we press W, A, S, and D, we can now move our player around across the screen. So this is pretty cool stuff. This is already kind of cool for me because this is normally not how you work with the terminal, so it's kind of cool that you can just kind of move a character all across the screen like this. But that's not really a game. We don't have any interactivity with this, so let's go ahead and add some things for the player to do. In the game initialization section, I'm going to add a list of coins, and the goal for the player is to collect all of the coins to advance to the next level. So I'm going to create a new variable called coins, and this is going to be a new slice of sprite pointers, and inside of there I'm just going to add a few entries. So we're going to do new sprite here, and for the character I'm going to put 0 to denote a coin, and then for the positions I'm just going to put some random positions, so like 12 and like 4 right here. And let's just add like 3 of them for the first round, and then let's make this like 8, and let's make this 2 and 14 like that, just to have a little bit of variety in that stuff. Inside of the draw logic, after we draw our player, we can loop over our coins. So we can say for underscore coin colon equals range our coins like this. Then we want to say coin.draw, pass in that screen, and we should be good to go. If we do go run dot on this, as you can now see, we have 3 coins like so. But if we walk over them, nothing happens because we haven't, said to do anything. So what we need to do is add the logic for picking up some coins. So what we need to do is first check if the player has moved. If the player's moved, we need to check if the player has collided with any coins. If the player's collided with a coin, remove it from the list of coins. So that's the basic pipeline. Let's go ahead and implement it. Before we check for our keyboard events, let's store a flag for our player. So I'm going to say player moved colon equals false. And then whenever we move with W, A, S, and D, we'll set player moved to true like this. So let's just go ahead and paste that into all 4 of those. And what this will do is it'll just keep track of whether we have moved during this frame or not. Next thing we need to do is after we do our switch statement for our event, we are going to then check for coin collisions. So we'll say if player moved, then we need to loop over the coins and check for collisions with them. So we'll say for index coin colon equals range coins, and then we'll say if coin.x equals player.x and coin.y equals player.y, then we want to actually collect the coin. But removing items from a slice while we're looping over the slice is not a very good practice. And so the way we'll actually keep track of picking up a coin is we'll have another flag up here, and we'll say this is the coin collected index. And I'm going to set it with an initial value of -1, which is not a possible index. So then we're going to say the coin collected index is going to be equal to the index inside of our for loop. So this right here. Now what we need to do is we need to handle coin collision. So we'll say if coin collected index, and then we're going to say is greater than -1, then we want to remove it from the slice. So a quick little trick for removing one element from a slice that does not need to be sorted is we can swap that item with the last item in the slice, and then we can just trim off the last item in the slice. So let's go ahead and do that now. We'll say coins at the coin collected index equals the coins at the length of coins -1 here. Then we can actually just trim off the end, so we can say coins equals coins from 0 to the length of coins -1. So this is basically swap target with last and then trim off last item. Okay, so now what we can do is we can go over to our terminal and run it again, and let's see what happens when we walk over some coins. As you can see, when we walk over the coins, we are collecting them and they are going away. So cool, we've added coin collecting functionality to our game. But now we need to add an actual incentive for picking up these coins. And for this, I'm going to be adding a score to my game. So inside of our game init section, I'm going to add a new variable called score, and I'm going to set its initial value to 0. Then whenever we do collide with the coin, I'm going to be incrementing the score, so score plus plus like this. And that is a basic score system implemented in 2 lines of code. But we don't really have a way of debugging this because we can't put a print statement here because we're actually using the terminal for the game. And if we put a print statement, it will simply not show up. So what we have to do is we actually have to create some UI to display text in our game for our score. Which sounds intimidating, but it's actually really not that bad. What I'm going to do is I'm going to create a helper function here, and I'm just going to call it my draw string function. This is going to take in the screen to draw to, so tcell.screen like this, and then it's going to take in the x and the y of the thing we want to draw, and then the actual message that we want to draw like this. Next thing we need to do is we need to loop over all the characters in the string. So we'll say for index character colon equals range message here. And then what we need to do is we need to do screen.setContent, and we're basically going to be drawing each character one by one. So x, y, and then the character is going to be char, nil, and then the tcell.default style or style default. And then for the x, we need to add on that index to be treated as the offset as we move along the sentence here. So we're starting at the very far left, and then we're working our way towards the end of the character list. So now what we can do is we can add a new section to our draw logic. This is where our draw logic is happening. So after we are drawing our player and our coins, we can add a UI section here. And inside of there, I will do a draw string call, and then I will pass in the screen. And then for the X, I'll put in 1. And then for the Y, I'll put in 1 as well. And then for the message, I'm going to make use of the sprintf function to format a string with some variables with the score variable that we want. So it'll be score colon, and then it's %d, I believe. And then we need to pass in the value we want to substitute in for d, which is going to be the score. And that should be enough to actually draw our UI on the screen. So we can go back to our terminal, go run dot. And as you can see, we now have score is equal to 0 at the top. We can then go over these, and as we pick up coins, our score is incrementing by that amount. So that's great, but our game is kind of boring because the coins spawn in the same place every single time. So when we're done collecting our 3 coins, we no longer have anything to play. We can easily upgrade this by making a function that will generate coins at a random location and at a random amount depending on the level. We can go up here, and I'm going to create a new function, and this is going to be called setup coins. This will take in a level, which is just a number corresponding to the level that we are on, and this will return our list of coins. So list of sprites like this. First thing we want to do is allocate that new list of sprites, or that slice of sprites. So I'll say coins equals make, and then inside of here, we will create this new slice of sprites. And then for the initial size, I'm going to do the level number +2, because basically what I want is the first level to have 3, and then from then on, every level will add 1 new coin onto the amount to be spawned in. So this will create, for level 1, it will create a list of size 3, and then for 2, 4, and then for 3, 5, etc., etc. Now what we need to do is simply loop over all of the indices from 0 to that size and insert them into this coin slice here. So we'll say for index colon equals range, and we want to do level +2. And then what we need to do is we'll say coins at this index are going to be equal to a new sprite. And for the sprite for the character, we're going to be doing 0 for the coin. I'm going to be using the rand package inside of the math package. So we're going to do random dot, and then we have an int n here, which generates numbers from 0 to n. And so for this, I'm going to do 20. So it's going to be 0 to 20. And then for the y, it's going to be the exact same thing like that. Finally, we need to return that list at the end. So we'll return the coins, and our setup coins function is done. Now what we can do is we can set up our coins differently from how we were before. So we can go over here, remove that, and we can say setup coins and pass in the first level of 1. We can also keep track of the level below our score here. So I'm gonna make a new variable, call it level, and set it to 1 for the first level. The final thing we need to do for this is after we do remove a coin from the list, we need to check if the list of coins is empty. If it is, then we need to refresh it and increment the level. So we'll say if the length of coins is equal to 0, then we need to say that the level plus plus, and then we need to say that the coins is equal to setup coins with that new level variable like that. Finally, we can do go run dot, and we can move over here, collect that coin, go over here, collect this coin. And as you can see, we have 4 coins now. We can collect those coins. We now have 5 coins, so we can go over here and collect all those, etc., etc. We basically have a game with an infinite game loop here, so that's pretty cool. And the final thing for me is I'm going to add a thing that keeps track of the level that we're on. So I'm going to add a new drawstring call after our score one. This is going to have the level, and then I'm going to pass in the level like this, and then I'm going to change the y to 2, and let's see how that looks. So if we run the game here and we move around, we can collect this one here and collect that one there. It seems like one of our coins was inside of the UI, which is something that we could fix later. But as you can see, we now have something keeping track of the level we're on, which is very cool stuff. So that's about it for this video. We have a very simple coin collecting game with an infinite loop. Hopefully you learned something new, and if you did, consider liking and subscribing. If you enjoy videos like this and you want more about like making a terminal game or something like that, make sure to let me know in the comments. I myself really enjoy projects like this, so I'd really appreciate also knowing that y'all want that too. Also consider joining my Discord, link in the description. There are a bunch of developers and game developers that would love to talk to you and answer your questions. And also consider supporting me on Patreon so I can continue making videos like this. Thank you very much for watching. Have a good day. See ya.